Okay, so let's see if we can do a little bit of matching. We won't go through all of these, but we need to match these slope fields to these derivative equations, or yes, derivative equations. So we're looking for certain properties, right? And when I look at these, E and D stand out most to me. Okay, it looks like E is not defined for y values that are less than 0 or maybe even equal to 0. Okay, so when I look through these different functions, which of these functions in part are not defined for y values that are less than 0? And I can see number 5, right? We can't take the natural log of 0 or a negative number. All right, and we're doing natural log of y. So the slopes would be undefined. There would be no slope value here for these e's because the function's not defined there. Okay, so 5 goes with E. All right, I'll leave D to you to figure out which function it matches and why, but a similar reasoning. Okay, think about which values the function may not be able to take on. Okay, let's maybe do another really nice clue is if you can identify where a particular x value where it's always going to be 0, right? So when I go to x equals 0, we have these horizontal tangent lines, and so that means the slope is 0. Can I look at any of these functions and tell that it will be 0 whenever x is 0? Okay, so I'm just kind of looking through. Okay, perhaps 7. All right, if x is 0, then dy dx is going to be 0. Okay, so we can kind of test that theory if I go over to, let's say, x equals 1. All right, then if y is positive, then we're going to have negative slopes. Okay, and the larger y gets, the more negative that slope is going to be. That's what I'm kind of seeing in this particular slope field, right? And then just to continue to test that theory, if the y's are negative, okay, then our slopes are going to be positive. But as y gets more negative, the whole thing gets steeper, right? So this looks like B looks like it could match number 7, and it does. And we could continue, checking until you're convinced that it works. Okay, let's maybe look at one more. Let's take a look at C. One thing I noticed about C is that it looks like the slopes are all positive, okay? Always increasing, all right? So if I had to try to match this to one of the functions below, then I might look for something that looks like it'll always be positive. So when I look through the different functions, this can't always be positive because x could take on a negative value, so it's not number 2. We know that sine oscillates between 1 and -1, so it's not clear that that would always be positive. We know cosine x oscillates between -1 and 1. But number 6 looks like it would always be positive, right? Because we've got y squared plus 1. Okay, so looking at C, we see everything's always positive. The other thing I notice about C is that, or not C, but 6, is that it doesn't have an x term. What that means is the x value has no impact on the slope or the value, just the y. So when I look at this, I can see it's the same. Once I get on a line for y, it doesn't change, right? Because the x value doesn't matter. All right, so that's another kind of hint, is if you can identify that, oh, for this fixed y value, it's the same no matter what x is, then that means x is not a part of that equation. So 6 would be a good match for C.